Hello, welcome to the machine learning at home. Statistical bootstrap is, on my view, is one of the most wonderful methods which was developed for last 50 years. His author, Bradley Efron, is an American statistician. He is now over 80 years old, but what's interesting, he still continues to develop, and he is doing some stuff in R. So very recently I found a package in which Bradley Efron was participated, and that package allow you to make a bootstrap estimation of confidence intervals in a very easy and fast way. So name of the package is BCA boot. Let us load it. BCA boot. Okay, if this command is not working for you, don't forget you will need to install it first. So like type install.packages in the plural and in quotes the same BCA boot, and then make this command again. Okay, suppose you already have this package installed and everything is loaded. So what to do? So how to understand what it is doing? For example, you have some statistics. One of the interesting statistics is kursiosis. So kursiosis is a thing which shows you how tall is a particular sample distribution. Let me show how it works. So let us first of all kind of freeze random number generator, then you will have some similar results to what I will have in my computer. So set seed. For example, any number will work. The important thing is should be exactly the same on your computer. I will set it like 0. And now I will make a sample. Like we'll make a sample called AA, sample from some very large amount of numbers from 1 to 2 in 15th degree, and I will sample like 100 numbers. It's very fast in R. So now I need to show you what is a kursiosis. Let me show you with some graphical example. For example, we can plot so-called density of the distribution, and you will see what is it. So kursiosis is kind of tailedness, how sharp is the topmost peak, how narrow is the distribution, and how tall is the peak. I think you understand it, right? So now we have that kursiosis visually, but how to calculate it? There is multiple ways in R. Most simple is probably load the library E1071 and then use command kursiosis from that same library. It's like a minus 0.98, which means not a very good kursiosis. It's kind of not like a mountain, it's mostly like a hill. It's okay, but now next question, if you really work with your data, the next question is how good is this number? Can I use this minus 0.98, or my number might be different? For example, in my sample slightly changes. How this number will change? So this is kind of statistical robustness. What is bad about kursiosis? There is almost no way to calculate very common p-values, so you cannot do it, unfortunately. What to do? Bootstrap. Bootstrap is a universal way to understand robustness of any statistics. You only need resample, actually reshuffle your data multiple times, preferably thousands of times, and then see how your kursiosis will change. If it will be around minus 0.98, then it is good, it is stable. If it will change significantly, then probably you cannot use it straight away. So let me show how BCA boot works. So typically most of libraries in R which using Bootstrap can do it, but BCA boot is doing it in a very fast and I would say elegant way. So you only need one command, BCA jack, and you need to provide it with a sample which is AA, with a function which you need to use, which is kursiosis. And finally, you need to tell how many times you want to bootstrap. Actually, the algorithm here is very fast. So I would say 10,000 times. Sometimes 10,000 will be slow. In that case, it will not be very slow. You will see it very soon. Okay, let's do it. The progress bar. It's actually very fast. And now, what is output? Look on that output. So that number, like it is -125031014. It is a left margin, and this number is -0.594298. It is a right margin. So your value will change between -1.25 and -0.59. We call it 5% confidence interval, or even better, mostly people say it 95% confidence interval, because this is a left margin, it's a 0.025, so 2.5%, and the right interval is 0.975, so the right 97.5%. So altogether it will give you like 95% of the whole distribution. So only 2.5% will be cut from left and from right. So if we cut this, your value will change from -1.25 to -0.59. And your estimation is here. It's -0.98. It should be more or less in between these two numbers. It actually is. And the mean of all bootstrap is slightly lower, like -0.96, actually closer to 0. So this is your results. I would say you can of course use multiple statistics, which also stated here, but if even you use -1.25 and -0.59, it will be enough. So your value is not bad. It's not going very much over or very much lower. You can use it, and always if you make a paper, for example, you can always say my 95% confidence interval for that value is from -125 to -0.59. And again, this is just a simple demonstration how effective, easy, and fast is the package which author of Bootstrap, of course, Bradley Efron, received lots of statistical prizes for his development, and he is still doing some interesting stuff. So this is how to estimate confidence interval in an easy and a fast way in R. Thank you very much.